I'll try to keep this video as simple as possible and explain what DSA really is, like I'm explaining it to a 5-year-old. Hello there, this is the intern, and today I'm gonna talk about data structures and algorithms as a beginner. So, you might have overheard people talking about DSA and how having a good DSA expertise gets you a job into big tech giants. Or you might just be a freshman trying to discover your opportunities. Either way, this video will be a good starting point to understand what DSA truly is. Now, I'm not an absolute beginner or an expert on DSA. As of now, I'm cruising through my learning curve of maybe acing data structures and algorithms. So, what is DSA and why is it that important? Let's learn it all with a very simple example, like I always do. Given a list of unique numbers sorted in an increasing order, find out all pairs of numbers which sum up to a given value. You might also be given a test example. Let's go with 3, 5, 8, 12, 18, 20, 25, with the value being 23. You can very well see the answer being 18 plus 5 and 20 plus 3. Easy for a human to say, but you can't work it yourself on huge lists. Typically, there is a constraint given to each of these questions, like the length of the list and the range of values for each number. Most people tend to overlook this, but it has a very important role in choosing the algorithm or data type you would use. I'll just let it slide for now. As a complete newbie, let's just apply a naive solution to this. Since there are n numbers and we have to find all pairs of numbers that sum up to a given value, we might be tempted to just find out all pairs of numbers there is and pick the ones that sum up to the given value. It's that simple. We can have two pointers x and y doing it. X stays in position while y iterates through the entire list and finds the sum we need. When y reaches the end, x moves the position and y starts again. Mathematically, there are NC2 combinations that are found here, simplifying which gives us a quadratic polynomial. This lets us set the range for what we call an asymptotic function. When the value of n is large in this function, n squared will have a greater influence on the entire function than simply minus n. Hence, we like to say that this algorithm has a worst case time complexity of big O of n squared. Frankly speaking, this is a very bad algorithm to use as we are taking into consideration all pairs blindly and just picking the pairs we want. This is not utilizing the fact that the array is sorted and we have so much more to do. Now let's change the algorithm a little bit more. Let's keep the x pointer as it is, but we'll do something different with the y pointer this time. We'll run a binary search algorithm on the right side of the list. Now what's that? When we have x set on the first number, we need y to be value minus the number of x to be a successful pair, right? So what if the number of y is less than value minus the number of x? Well, we move right. If the number of y is more than the value minus the number of x, we move left. How do we achieve this? Well, we simply take the middle number on the right side of the list as y and keep going on with the algorithm until and unless the window of search closes. This algorithm for once is far better than the one we were using before because we are not blindly considering all possible pairs but we are smartly trying to find out what suits best. The worst case time complexity of binary search is big O of logarithm of n. I'll not go into the mathematics of that just yet, but combined with the pointer x moving from left to right, it gives us a total time complexity of big O of n logarithm n. Now that's a lot better than that of n squared. Okay, so this algorithm seems good enough. Are we done yet? Um, there's one more algorithm that can do the entire job in a time complexity of big O of n. This time, let's keep the pointer x and the pointer y on the extreme sides of the list. The idea here is to again find what sum the two pointers add up to and move accordingly. If the sum is greater than the value, the right pointer moves left to compensate for it, else the left pointer moves right to increase the sum. It's that simple. But when do we stop? We stop when the two pointers meet each other in the middle. How romantic. Now, for those of you who are not from a mathematical background, I'm just gonna plot the curves of each of these algorithms, the asymptotic complexity curves of each of these algorithms here, so that you can judge for yourself which suits best. Now you can very well see how efficient the latest algorithm is in computing the answer. That's because we are using the fact that the array is sorted smartly in the latter algorithms, whereas we were brutally trying to get to the answer in the first place. I hope this gives you the slightest idea of how important algorithm design really is. Now the same can be said about data structures. Now data structure is simply a way to store data. I'll not go into the definition just now, but I'm gonna just take two examples and compare them. Let's go with arrays and linked list, both similar linear data structures but with big difference. An array is like a scale. You cannot expand its length, but it has markings on itself. A linked list is like a chain. You can expand it from any side, even from the middle, but it does not have any markings. That's basically it. When you are trying to get a fast and responsive data structure where you will immediately get the value stored in, let's say, the fifth place, you should use an array. But when you need a data structure with fast insertion and deletions, you will need a linked list. You can simply add a new value on top of the list without having to transfer it all on a new, bigger list, unlike an array which has a fixed size. And that is basically it. I hope you guys get even the slightest idea of how important data structures and algorithms are and what they actually are. Now, big tech MNCs always hire people with good DSA skills paired with other skills like web development or maybe data science as required in their portfolio. Either you are preparing for interviews or just want to have fun increasing your rankings in competitive programming, DSA is the way to go. I like practicing most from leadcode.com. Now, I'm not a competitive programmer, so I don't tend using CodeChef or CodeForces, but LeetCode is a good platform to practice your coding skills, your DSA skills on questions that are actually used in interviews. Okay, so with that, thank you guys for watching, and I'll see you guys very soon.